Hi, good evening. I'm Jason Kelly. I go to the Liverpool Bluecoat School, so fortunately, and I'm reading this book now, physics. It's this one I'm reading about particularly. It's the wave particle duality, and what I love about this book here, if you can see it, is just how much the examiners care, how much you really want the students to maximise their explanations to as much as possible in order to gain their marks, and then not to succumb to the many pitfalls there are that students have previously done. And so, based on exams they've marked in the past, they look through them and they give these little side notes, see here, as tips. And this one in particular, this examiner's tip says, don't mix up matter waves and electromagnetic waves, and don't mix up their formulae. So I think that's really good of them, I look at it and I think, yeah, pretty much throughout all the pages you find things like this. There's another one. I mean, what does it say? It says, again, don't forget that lines in a spectrum are always due to energy levels. So, yeah, I mean, this one says a photon can be absorbed and cause ionization if its energy is greater than or equal to the difference between the ionization energy and the ground state, although excitation requires photons of specific energies. Whoa. And, oh look, brilliant, another one. This one I can't read upside down, but this one says, don't confuse atomic electrons with electrons that hit the atom. I mean, wow. Wow, wow, wow. Whoa. I mean, I've been reading a lot of this book because I want to do well myself. Yeah, I really love this book. I mean, look, another examiner's tip. This one says, oh, look at it. It says light, lepton equals light and weak, and hadron equals strong and heavy. Indeed, that's true. Because we all know that the hadrons only interact through the strong interaction, whereas the weak one, the leptons, they interact through the weak, namely the electrons and muons and stuff like that, taus and all that kind of palaver. Look, it's put on this book even a bullseye. It's kind of like making sure it's secretly subliminally implying that we should aim for the bullseye. That's why it's even making it easy, because that's a pretty big bullseye compared to normal bull's eyes. Normally they're really small, but examiners want to make it as easy as possible for us to get our target grades. So it's always like putting in these secret reminders. I mean, ooh, look at it all. Oh my goodness. When does the computer ever look like that again? They're all gone in that microwave. It's a bit dated. So what I actually quite like superfluid and the resistance to flow and how they can actually creep up a container despite being contained. I think it's amazing. Absolutely amazing. I've never heard anything of the likes of it, but I mistakenly thought it actually meant that it could actually creep and sweep through the container itself, but it can. I don't think it could do that even at 2.73 Kelvin for the temperature below helium at which it becomes a superfluid, but I don't know, but there you go. Well, I've been Jason Kelly, and I hope you've enjoyed my little explanation on why I like this book and a bit of particle physics. Yeah, goodbye!